but we'll keep at it and let me know if there's anything I can do for you, okay? All right, so let's go ahead and finish the chapter. We've only got a few slides to go. So we talked about marginal utility. Marginal utility being the additional satisfaction you get from consuming something. We know that if that utility, that marginal utility follows the law of diminishing marginal utility, that marginal utility will go down with each additional unit that you consume. We know that's not a perfect science, right? But we know that for the most part, that does hold true. So now what we're going to do is we're going to make a connection between marginal utility and the law of demand, which says that there's an inverse relationship, right, between price and quantity. So I think this is an interesting connection to make. Marginal utility, your marginal utility, actually helps determine a point on your individual demand curve for every single solitary good out there. That the combination of the price, your income, and your taste for that good are the drivers behind maximizing utility. So you pick that perfect combination of good based on the price of the goods, your income, and your taste for each good, okay? So let's take a look at a demand curve and let's see if I can illustrate that concept. All right, we're gonna say that this is your demand curve for pizza. It's yours. It's for one single solitary person. Nobody actually draws a demand curve for themselves, okay? But if we were going to, I'd draw this one for you, okay? You can see here that we have prices of pizza from $2, $4, $6, $8, and then we have quantities of pizzas you would consume per week. That is your downward sloping demand curve. There are 2 points that we've indicated on that demand curve, point A and point B. Point A is how many pizzas you would demand at $8, and then how many pizzas you would demand at $6. Obviously, you demand more pizzas at $6. But here's how marginal utility comes into play here. If I'm gonna get you to buy more pizzas every week, I need to decrease the price of my pizzas. Not when you get to your 5th pizza a week, because I can't really look at you and say, okay, so you've already had 3 pizzas this week, and so your 4th pizza, I'm gonna discount the price just for you. It's not really how it works, right? The price of the pizza is the price of the pizza. But if I want to get you to buy more of my pizzas every week, I have to decrease the price of those pizzas. And here's why. Because while you might value that first pizza in the week at $8, or in this case, your first 3 pizzas in the week at $8, that 4th pizza, you don't value it at $8. You've had a lot of pizza already, right? Your marginal utility for pizza is going down. So if I want to get you to buy a 4th pizza every week, I actually need to give you all of the pizzas at a lower price. In this case, it would be $6 in order to get you to buy that 4th pizza. And if I want to get you to buy a 5th pizza, I'm going to need to take the price even lower. And if I'm going to get you to buy a 6th pizza, I'm going to need to take the price even lower than that, right? A place like Little Caesars, who sells you $5 pizzas, is pretty sure they can get you to buy multiple pizzas every week by setting the price so low. And they actually do a large quantity of pizzas. And so that's how they make their profit, right? It's just a different business model. But there is a relationship, right, between what you're willing to pay for a pizza and how many pizzas you've already had that week. So probably that first pizza, and this demand curve, it's hard to say if it really ends here or what, I really can't tell. But the first pizza you consume in a week, right, you're probably willing to pay a little bit more for because it's your first one. But your second one, you're willing to pay a little less for because it doesn't give you as much marginal utility because marginal utility is going down. And that would explain why the demand curve, an individual's demand curve, and therefore every demand, not every, sorry, most demand curves are going to be downward sloping. Because if you want people to consume more, You have to decrease the price because they're simply not going to get the same satisfaction out of their fourth pizza in a week than they did with their first one. Okay? All right. So then that brings us to a concept we call consumer surplus. This is really, really important. We will talk about consumer surplus over and over and over again in this class. Okay? You got to understand what it means and then understand how to calculate it and how to look for it. Okay? Consumer surplus is the difference between the most a consumer would pay for a given quantity of a good and what the consumer actually pays. For example, you have $4 in your hand because you need a gallon of milk. So you walk into the grocery store with $4 in your hand. Because of market exchange, because of supply and demand and markets and market equilibrium and all of that stuff, you walk up to the dairy case and the milk's $3. You were willing to pay $4, you only had to pay $3. The difference is what we call consumer surplus. It's the difference between what you had to pay and what you were willing to pay, sort of that maximum you were willing to pay. I'm going to assume that you wouldn't have paid any more than $4, right? That was the max that you had to spend on milk that day, okay? But you got that $1 of consumer surplus. What are most of us going to do with $1 of consumer surplus? Somebody tell me, what are you going to do with $1 of consumer surplus? I feel like somebody's talking and I can't hear them. Yep, sorry. We've had terrible luck with speakers this morning. Why doesn't somebody type it in the chat box? What are you going to do with that $1 of consumer surplus? Buy something else. Spend it on something else. Sorry, guys. I don't know what's going on with speakers in classrooms this morning. But I guess it's better for you to hear me. So, is that a good thing for an economy? Of course it is, right? If you have people that still have money in their pockets to spend on something else, that stimulates another market. We call this consumer surplus. This money you put back in your pocket to spend on something else. It's a beautiful thing. And what we're going to talk about as we go through these next few chapters is what it means, what different types of markets, different market setups do in terms of consumer surplus. Whether they provide us additional consumer surplus or whether they take away our consumer surplus, depending on how the market functions, what type of a market it is. There's lots of different types of markets. And so this concept's super important, okay? All right, so as we go down here, I'm gonna show you how we calculate consumer surplus for an individual. Now, this is kind of a funky way to look at consumer surplus because we're looking at consumer surplus for one person, which we never do. And so the numbers are kind of funny because we're buying whole units of sub sandwiches. Typically, when we're looking at consumer surplus, we're looking at consumer surplus for an entire economy, an entire market. And so we're talking about thousands, millions of units, whatever. So it doesn't look like, it doesn't have this kind of stair step effect that it does when we're looking at a graph for just an individual. Just bear with me, okay? All right, so let's assume this is your demand curve for sub sandwiches, and you can only buy sub sandwiches in whole sandwiches, okay? So your demand curve tells me that at $8, you demand 0 sub sandwiches. And I'm getting the information off your demand curve, that downward sloping green curve. At $7, if I go over to the demand curve, it tells me you demand 1 unit. So if sub sandwiches are priced at $7, I know you're only going to buy 1 per month, okay? Now, if I go down to $6 and go over to the demand curve, I can see that you demand 2 sub sandwiches if they're priced at $6. Well, wait a minute. You were actually willing to pay 7 for the first one. We actually know that looking at your demand curve. But what if you get both of them for 6? Well, A, you're going to buy an additional sandwich. We know that, right? You're going to go from 1 sandwiches to 2 sandwiches. But you're also going to gain consumer surplus on the first sandwich. So right here, this little rectangle, if we take the area of that rectangle, base times height, base is 1, height is $1, 1 times $1 is $1. We know that you received $1 of consumer surplus if those sandwiches went to 2. So you bought, I'm sorry, those sandwiches went to 6, so you bought 2. So on that first sandwich, you got $1 of consumer surplus. Now let's assume sub sandwiches are $5, right? And so if I look at your demand curve, I know at $5, you're gonna buy 3 units. Well, I know you were willing to pay 7 for the first one. I know you were willing to pay 6 for the second one, but you didn't have to. You got them all for $5. And then you got that third one for $5. So you had no consumer surplus on that third one. You had 1 unit on the second of consumer surplus. And when I say 1 unit, it's $1. And then you had $2 or 2 of these little units of consumer surplus on the first unit. So you had $3 of consumer surplus that month if the price of subs were $5 and you bought 3. Because you don't get as much satisfaction the more units you buy per month. So if they want to get you to buy more units per month, they have to have a lower price. Not just for that last unit, but in total. Okay? All right. Any questions about that? Put it in the chat box. Sorry. Everybody good? Okay. Consumer surplus is the area below the demand curve and above the price. So it's this triangle. Okay? So here's $5. Okay, that's the price, let's say, for sub sandwiches. Here's your demand curve. It's this area in here. It's usually like a triangle or a wedge of some sort, okay? Now, normally you don't have this stair step thing going on and you can just take the entire area, right? Because there's so many units being sold. But in this case, right, we actually have to add up the area of these little tiny blocks. You really won't see it like this again, because we're going to just talk about huge numbers from this point forward. All right, I'm going to assume we're good. Okay, so market demand and consumer surplus. The market demand curve, demand for the entire market for sub sandwiches, is the sum of all individual demand curves in the market. We already talked about this in chapter 4. So that individual sub demand curve, we're adding up everybody's individual and it's giving us the market demand curve. But it follows the law of diminishing marginal utility because we can get people to buy more if the price is lower, right? Because if they're gonna buy more, they're not gonna get as much satisfaction, so they're not gonna be willing to pay as high of a price. Okay. Consumer surplus is the net benefit that consumers get from market exchange. Okay, so if you took that $4 that you were willing to pay for milk and you walked up to a dairy farmer and said, here, I have $4 and I need a gallon of milk. How much money do you think they're going to take from your hand? Any ideas? They're going to take $4 because we're not participating in really a market. I'm walking up with $4 in my hand saying, I want a gallon of milk. The dairy farmer's gonna be like, yup, I'll take the $4, here's your gallon of milk. But because you go in a grocery store where all the buyers and sellers of milk converge, you end up with the equilibrium price, which is typically a lower price, okay? All right, let's switch gears now and bring up the worksheet. Everybody go get your worksheet. It's on BB Learn for any of you that didn't realize we were doing a worksheet today. Just a couple quick things about the worksheets. I got probably 3 dozen emails last time we did a worksheet of people turning in worksheets late, wanting to turn in worksheets late. I cannot accept late worksheets. It is what you get from coming to class, is you get the opportunity to get the worksheet done, get it right, and submit it right away. If you have problems submitting your worksheet, email it to me right away. During that time period that you could have submitted on BB Learn. If you send it to me at noon today or at midnight or tomorrow morning, you will not get the points for the worksheet. It is the benefit of coming to class, okay, and submitting on time. All right. Let me see if I can figure out how to get the worksheet to just come up here. You can always write these on a piece of paper. That's a great question, Madeline. You can always write this on a piece of paper. I'm not going to ever penalize somebody for not having a printer at their disposal. Do your best. What's important is not to write like all the, sort of explanatory verbiage or anything like that, because that's available to you, right? You can add that later. But it's important that all of your answers be there, okay? Skogan, thanks for that advice, downloading the PDF. Awesome. I wish I could hear your voices, people. All right, makes it real lonely on my end. Okay. So the first thing we're gonna do is we're gonna do this top part of the worksheet, filling in this matrices. So this is exactly what we did on Wednesday when we were doing this consumer equilibrium problem. We did like pizzas and movies. Here we're doing movies in a theater and movies in a video store. So the first thing you need to do is fill in all these little blanks here on this worksheet, okay? Now, I'm gonna do a couple for you just to sort of get your brain thinking in the right direction, okay? So, we have quantity, we have total utility, we have marginal utility, and we have marginal utility per dollar. You just need to fill in all these random blanks. This is like simple algebra, okay? Marginal utility adds up to give you total. So this plus this should give me 200. So I know that this is 200. This plus this plus this should give me 290. Yes, it does. That looks right, okay? This plus this plus this plus this should give me my next total, okay? So that's gonna be 370, because I'm just adding down and plugging the number into the total. So the marginal adds up to the total. You sometimes have to back into those numbers. Marginal utility per dollar is marginal utility divided by the price. Each movie ticket costs $6. Each video rental costs $3. That's the number that you need to be dividing by, okay? So in order, well, this one you need to fill in, but here, 30 divided by 3 gives me 10. Okay, you go through and fill out the matrix, and then if you're so inclined, you can start working on the following questions. Post any questions that you have in the chat box. You got to understand these calculations, so please try and actively fill this in. You're going to learn so much more that way than just waiting till the end and watching me fill it in. That's not going to be helpful to you. The total, Delaney, is a sum of the marginal. So like for this example here, like 0 plus 200 plus 90 plus 80 would have given me the 370. So we just continue to add that additional number. So how you would get this total utility is you'd add up all of this down and including 60 and throw it over here. Powell, that's not a percentage. That's marginal utility divided by price. So it's like dollars per unit of marginal utility. So that's division. Here you have your marginal utility. Here you have your price. So take this, divide it by 3, and that's how you get your marginal utility per dollar. So the P is price. Marginal utility divided by price. I hope that helps. Yep. I'll give you a couple more minutes. Okay, I'm just gonna start kind of filling them in just to make sure you have them all right, because it's gonna be really hard to get C correct if you don't have the right numbers filled in, okay? So this would be a 500 here. I would have added all of these up, gotten 500. I would have had to sort of back into here. What number would I have added here to go from 500 to 550? Well, I would have added 50, right? The difference. So the difference between these numbers are actually the marginal because you're adding, right? And then the marginal utility per dollar, 90 divided by 6 would have given me 15. 60 divided by 6 gave me 10. So 0 plus 250 gives me 250. How do I get from 250 to 295? What number would I have needed in order to make that math work out? Well, I would have needed a 45. 45 divided by 3 would have given me 15. And then we did the 30 divided by 3 to get 10. Okay? Any questions about any of that so far? All right. So let's go down to B. Do these tables show that Becca's preferences obey the law of diminishing marginal utility? Explain your answer. So that's column 3 and 7, the marginal utility columns. Do those obey the law of diminishing marginal utility? Yes. Why? Well, because they diminish, right? So with each additional unit, you can see marginal utility goes down or diminishes for both of these, okay? So your answer would be yes. Thank you, Dennis. That's the perfect explanation. Her satisfaction actually increases in total. She actually likes every single one of these units. It never goes negative, right? But increases by a subsequently smaller and smaller and smaller increment, okay? All right. So I would put yes, right? Because as the quantity goes up, her marginal utility goes down. Something like that, okay? All right, here's where we really have to start doing the work. How much of each good will Becca consume in equilibrium? Let's remind ourselves what the two conditions of equilibrium are. Two conditions of equilibrium. We have to exhaust our budget. In this case, our budget's $36, okay? And the last unit we consume of each has to provide the same MUP, marginal utility per dollar. So what we're doing is we're looking for all the places that marginal utility per dollar is the same. And what you're gonna find is you have a lot of possibilities here. You have a 15 and a 15, 13.33, these are the same, these are the same, these are the same, these are the same. But only one combination exhausts the entire budget of $36. Why don't you guys take a minute to see if you can figure it out? And then I'll ask somebody to give me the answer. Here's the quantity, here's the price. You just have to test some of them out. In the case where I have so many that are similar, I might start somewhere in the middle because I'll be able to tell pretty quickly if I'm over budget or under budget, so I can either work my way to higher quantities or to lower quantities subsequently, okay? You don't really want to start at one end or the other when you have, what is it, 6 possibilities that you have to run. I would start with a 4 or 5, something like that. Somebody feels like they have the answer. Drop it in the chat box. Ben, I need a quantity. I'm looking for a quantity. And that's probably what you meant, Ben. 4 units of each. 4 units of each is the correct answer, right? It's the only place where you reach both of your conditions, okay? So with 4, and again, you just have to test it out to see, there's no magic here, right? 4 units times $6 per unit is $24. 4 units times $3 gives me $12. I add those together and I have exhausted my budget. I've exhausted my budget, and the marginal utility per dollar is the same for each last unit consumed. Any questions about how we got that? If you had done like 3 and 3 had been like the place you started, you would have found that you didn't exhaust your budget. So then you know you got to buy more to exhaust your budget. So then you would have gone to 4 and 4. Okay? Any questions about that? Okay, the next one's a little tricky. And I typically get students giving me the wrong answer for this initially. Okay? Why doesn't somebody see? Well, they're always, Jacob, this is a great question. In reality, I mean, right? Trying to find that perfect equilibrium at whole units of goods across thousands of goods would be close, right? In my class, in any example that you're going to get on homework or on exams or whatever, they will always be exact. I promise. Okay? Great question. Okay, so let's look at what you're being asked for D. Suppose the price of both types of movies drops to $1. The price has changed, people, to $1. What would be, and the budget shrinks to 10, how much of each of the goods would she consume in equilibrium? Devin, that's typically the wrong answer I get, is 5 of each. You neglected to do something. What do we need to do before we can tell? It's not 4 and 3. You guys are answering so fast that I'm thinking you didn't do the work you needed to do in order to solve for this. If your price changes, what else changes? Thank you, Ian. Ian has the right answer, and let me show you how he got it, okay? Your marginal utility per dollar now has to be recalculated based on a different price. You know how you took this 200 and divided by 3? Well, 3 is not a good number anymore. 6 isn't a good number anymore. Now it's a 1, okay? Well, coincidentally, marginal utility divided by 1 just gives you marginal utility. So this column is also your new marginal utility per dollar. So now you need to look in these two, and you need to find some place where marginal utility per dollar is the same. And it actually only happens at one place. This 40 and this 40. Okay? Well, when we do the math, it actually works out too. 7 units times $1 is $7. 3 units times $1 is $3. $7 plus $3 is $10. That's our whole budget. So it's 7 theater movies and 3 video movies is going to be the answer. Is there any questions on that? It's tricky. It was a trick question because I needed you to think about needing to recalculate marginal utility per dollar when you have a new price. Do prices change? All the time, right? Anytime a price changes, you have to recalculate marginal utility per dollar, right? You're going to learn it here and not on the exam the hard way, right? Okay, good. But for those of you who are like 5 of each, that is a really common answer I get because you initially go back up to your same chart and start looking, right? Okay. Any questions? Is everybody good on this? Okay. I'm so sorry I can't hear you. All right. So we're going to do the same thing again. Except for I've actually set up the information a little bit different and I haven't made it as user-friendly for you. What I've given you is just marginal utility. Marginal utility for good X and marginal utility for good Y. If you are going to find consumer equilibrium for a consumer that has $17 a month to spend on good X and good Y, you got to set yourself up a couple of columns so that you can find your consumer equilibrium, okay? What I would do, and I've left you plenty of room here, right, is I would add a little marginal utility per dollar column there. And so you could do your calculation. Your price of good X is $2. Price of good Y is $3. It's really a word problem that has you figure out what pieces of information you need and how to use them and how to put them together to come up with consumer equilibrium. So the first thing you got to do is that. So do that really quick if you haven't. And then you can start trying to figure out where your consumer equilibrium is based on a budget of $17. So 10 divided by 2 gave me 5. 8 divided by 2 gives me 4, so on and so forth. All right, somebody tell me where consumer equilibrium is. How many of good X, how many of good Y? No, Bryce, that was a possibility, but that actually didn't exhaust our budget. Thanks, Benjamin, that's gonna be it. So it's going to be 4 of good X and 3 of good Y. But Bryce, that's an important thing to recognize is see how there's like this one over here can either match up with 3 of good X or 4 of good X because these are both ones. So we would have wanted to test this to see if it exhausted our budget and then this to see if it exhausted our budget. So 4 of good X, 3 of good Y. Any questions? So 4 of good X, 4 times 2 would be $8. 3 of Y, 3 times 3 is $9. 3 units at $3 a piece is our $17. We would have only spent like $15 if it was the 3 and 3. So it wouldn't have exhausted our budget. Everybody good on this? All right, I'm gonna assume you're good. We're gonna flip this over. So let's do it again. Except for this time, there's 3 goods. Good A, good B, good C. This is exactly the same procedure. We just added another good because in reality, this is hundreds or thousands of goods, right? So let's just take it from 2 to 3. Again, you have to add yourself a little column in here to get the data you really need, which is the marginal utility per dollar. So just add a little column in here for yourself, right? And do your marginal utility per dollar. And then once you've done that, right, based on these prices here in A, so it's $2, $3 for B, $1 for C, okay? See if you can come up with the equilibrium quantity of each. And if you do that, start working on B. We have a change in price again. So just to get you started, right, that's 50 divided by 2, 25, et cetera, et cetera. 75 divided by 3, 25. 25 divided by 1 gives you 25. Okay, keep going. Right, that's a possible combination right there. 25, 25, 25, right? Budget of $24. Somebody comes up with the answer for A, go ahead and throw it at me. Four units of each. That is correct. 4 units of each. Thanks, Ariana. We would have found a marginal utility per dollar of 10, 10, and 10 here. We could have tried out all the different combinations, right? We had marginal utility per dollar across all 3 that were the same. And then you just had to do the math. 4 units at $2 a piece is $8. 4 units, $3 a piece is $12. 4 units at $1 a piece is $4. We add those all up. We got $24 spent. That exhausts our budget. All right, let's go on to B. Everything stays the same except the price of good A rises to $4. This is no longer good information for you. Set yourself up an additional column with your new price of $4. Do your math and compare across all 3. Your numbers are now a little bit different, right? The prices from the goods were right here in the question. Ethan, do you see that? Just right in the questions of A. Okay. Okay, good. No problem. And then the price of good A changes in B, but B and C stay the same. Somebody tell me what you get when you make that price change for good A and redo equilibrium. Two, 4, and 4. Exactly. Thanks, Jacob. 2, 4, and 4. So we now do 2 of good A, 4 of B, and 4 of C. Because 40 divided by 4 gave us 10, and we actually exhaust our budget, right? When we do this 10, and this 10. So 2 times $4 gives us that same 8. We just got it a different way, right? So we still have that $8 spent on A, and then we keep that 4 and 4, or that 12 and that 24. Okay? All right. So this is kind of an interesting exercise. Using the information you got from parts A and B, draw a demand curve only for good A. Be sure to indicate price and quantity for each point on the curve. You should have 2 points. You have 2 points on the demand curve that you discovered for good A. When we did part A of the question, A had a price and a quantity demanded at that price. Then for part B of the question, the price of A changed and you have that new price and a new quantity demanded. You have 2 pieces of information that came off of your demand curve for good A. Plot those 2 points on that graph and connect them to give yourself some little picture of what your demand curve might look like, given those 2 points. Okay? Give that a try. It's not hard, right? Okay, so part A told us that if the price of A is $2, the quantity demanded is 4. So at $2, quantity demanded is 4. And then part B said, if the price changes to $4, quantity demanded is now 2. So at $4, quantity demanded is now 2. Here is a little tiny demand curve for good A at those given prices. Any questions? All right, that's it for the worksheet. Don't